Hello friends, I am Vivek Kumar, Assistant Professor, Department of Electronics Communication Engineering, Faculty Engineering, Gurukul Kangdi Vishwavidyalaya, Haridwar. So today we are going to discuss adder subtractor circuit using operational amplifier. So this is the circuit of adder using operational amplifier. This is also called summing amplifier or summer. So operation amplifier is used in inverting mode, and at inverting terminal there are n number of voltage sources connected here, V1, V2, V3 up to Vn voltage sources, and these are connected through resistances R1, R2, R3 and Rn. There is a feedback resistor Rf, and the non-inverting terminal is grounded here. So as we know from virtual ground concept, that is potential of, if potential of non-inverting terminal is 0, so potential of inverting terminal will also be 0. So this is written here from virtual ground concept, V2 equal to V2, V1 equal to 0 volt. That is potential of inverting terminal is equal to potential of non-inverting terminal equal to 0 volt here. Now as we know, the potential difference is 0 between inverting and non-inverting terminal, so there is practically 0 current flowing inside the operation amplifier. So essentially current I1, this current will be equal to current I2, which is going to the output side of the operation amplifier. So we can write it as I1 is equal to I2 is equal to, let's say, I. So I can be written as, because potential of this point, that is V2, is 0, so we can apply nodal analysis here. So through this we can write I equal to V1 by R1 plus V2 by R2, that is V2 by V2 minus 0 upon R2 plus so on Vn minus 0 upon Rn, the total current, equal to the output current I2, that is I. It can be written as potential this, yani 0 minus V0 upon Rf, this resistor Rf. So now we can write V0 is equal to minus of, just solving this expression, Rf upon R1 into V1 plus Rf upon R2 into V2 plus so on plus Rf upon R1 into Rf upon Rn into Vn. And if let's say R1 equal to R2 equal to Rn equal to, let's say, some potential, some resistor R, so we can write it as V0 is equal to minus Rf by R into V1 plus V2 plus V3 plus so on and Vn. This was the adder circuit, in which output is proportional to addition of, algebraic addition of all the voltage sources applied at input side of the operation amplifier. So based upon this, we can take one example here. So this is the example. 3 voltage sources are connected here. V1 is 0.1 volt, V2 is 0.2 volt, V3 is 0.3 volt. These are connected through resistances 20 kilo ohm, 10 kilo ohm and 50 kilo ohm. The feedback resistor is 100 kilo ohm. So we can calculate output V0 is equal to, from the formula just derived, minus of Rf upon R1 into V1 plus Rf upon R2 into V2 plus Rf upon R3 into V3. And so we can write 100 kilo ohm divided by 20 kilo ohm into 0.1 volt plus 100 kilo ohm upon 10 kilo ohm into 0.2 volt plus 100 kilo ohm upon 50 kilo ohm into 0.3 volt. So this will give you approximate minus 0.5 plus 2 plus 0.6 volt. So this is the answer. Now subtractor circuit. So in this case, in this subtractor, operation amplifier is used in difference mode, that is separate voltage sources are connected at inverting terminal and at non-inverting terminal. There is one again feedback resistor RF. So output can be determined using superposition principle, because we have applied more than one voltage sources, and these are also at different or inverting and non-inverting polarities. So for simplicity, we have taken here R1 equal to R2 equal to R3 equal to RF equal to R. R3 is a resistor. This is called offset minimizing resistor. It is also taken as R. So when V1 is equal to 0, that is killing V2. So we have, when V1 equal to 0, that is killing V1 and operating V2. So in this case, V1 equal to 0 and we are operating V2 here only. So the equivalent circuit becomes like this. So V2 is operating only and V1 is grounded here. And because the voltage which is acting on non-inverting terminal, so this is also called non-inverting configuration. Now we can apply nodal analysis here to calculate VO2, that is V output due to V2. So through virtual ground concept, that is V1 is equal to VA is equal to VB, VA is equal to VE from virtual ground concept. So potential of VB can be calculated, but before calculation of VB, we have to calculate VA through this loop. So we can calculate VA. So VA can be written as V2 upon R plus R into R. This is giving VA equal to V2 upon 2. So VB is equal to VA equal to V2 upon 2. Now applying nodal analysis at node B, at this node. We can write 0 volt minus VB. So this is 0 volt minus VB upon R, and this is equal to this current equal to VB minus V output 2 upon R. Solving this, we get V output 2 equal to VB plus VB, that is 2 times VB. So V output 2 is equal to 2 into V2, that is equal to 2 into VB. So 2 into V2 upon 2, that is V2. So V output is equal to V2. Now when V2 is grounded, that is V2 is killed and V1 is operating, the equivalent circuit becomes like this. So V2 is grounded here and V1 is operating only. Again, this terminal is grounded, this terminal is also grounded. So essentially potential of this point, that is node A, will be 0. Now VB becomes equal to VA from virtual ground concept. So VA essentially is equal to VB equal to 0. So VB equal to 0. Now applying nodal analysis at point B, that is at inverting node of the operation amplifier. So we can write it as V1 minus V1 minus 0 upon R, that is this current, V1 minus 0 upon R is equal to 0, means this potential 0 minus V output 1, that is output due to voltage source 1 upon R. So 0 minus V naught 1 upon R. Solving this, we get V naught 1 upon V naught 1 equal to minus V1. Simple. Therefore we can calculate the overall voltage, that is total voltage due to both the sources, that is V1 source and V2 source. So we can write it as V naught total voltage output is equal to V01 plus V02, that is equal to minus V1 plus V2. So we can write V0 is equal to V2 minus V1. That is the algebraic sum. Now based on this we can take one example here. So this is the example. At inverting source voltage V1 is connected and non-inverting source voltage V2 is connected through 5 kilo ohm resistors. This is 2 kilo ohm resistor and the feedback resistor is 10 kilo ohm. We have to calculate V0. We have to find out this V0 output voltage. So we have to operate one by one, that is using superposition theorem. We can calculate V0 just described. So when V2 is equal to 0, this voltage is equal to 0, that is killing V2 source. The equivalent circuit becomes like this. That is when V1 is operating only. In this case, this potential is grounded, this terminal is grounded, this terminal is also grounded. Essentially potential of non-inverting terminal, that is VA, becomes 0. Now potential of VB is also 0 because through virtual ground concept VB is equal to VA is equal to 0. So VB is also 0. Now we can apply nodal analysis at inverting terminal. So now, or we can write directly from formula, that is V output 1 is equal to minus RF upon R1 into V1. We can write directly from formula or we can apply nodal analysis also, both are same. So this is giving V01 is equal to minus 2 times V1. Now when V1 is equal to 0, that is killing V1 and operating V2. So V2 is operating, V1 is killed. So in this case, this potential is grounded. This V2 is operating only and this terminal is grounded also. So from virtual ground we can say that VB is equal to VA, that is potential of inverting terminals is equal to potential of non-inverting terminal. So to apply nodal analysis at inverting terminal, we have to calculate the voltage at non-inverting terminal, that is VA. So now VA can be calculated. So VA can be calculated and it can be written as V2 upon 5 kilo ohm plus 2 kilo ohm, V2 upon 5 kilo ohm plus 2 kilo ohm into 2 kilo ohm. So this is VA. VA is equal to V2 upon 5 plus 2 into 2, that is 2 by 7 into V2. So this becomes the potential of non-inverting terminal, that is VA. So V2 is equal to VA. So V2 is also equal to, VB is also equal to 2 by 7 into V2. Now we can apply nodal analysis at node B. So we can write it as 0 minus VB. So this is 0 minus VB upon 5 kilo ohm is equal to VB minus VO2 upon 10 kilo ohm, that is feedback resistor. So solving we get V02 is equal to 3 times VB, that is equal to 3 into VB is given by 2 by 7 into V2, that is equal to 6 upon 7 into V2. So the total output response, that is total output voltage V0, is written here as V0 is equal to V01 plus V02, that is output due to both the sources. So this is essentially equal to minus 2 times V1 plus 6 by 7 into V2. Now this is adder subtractor circuit. So we have applied more than one voltage sources at negative terminal, that is inverting terminal, and more than one voltage sources at non-inverting terminal also. So for simplicity we have taken all the resistor equal to R here. So these are voltage sources V1, V2, V3, V4 operating voltage sources here. This is R resistor, this was offset minimizing resistor. So to calculate V0, again we have to apply superposition theorem, that is we have to take algebraic sum of all the sources operating one at a time and killing rest of all the sources. So case number 1, in first case, when V1 is operating, that is V2, V3, V4 is grounded, that is V2, V3, V4 are killed here. So only V1 is operating. So V1 is operating, V2, V3, V4 are killed, that is grounded simply. Again, this potential is grounded, this is also grounded, this is also grounded. So essentially potential of node A, that is VA, is equal to 0. So potential of VB, that is node B, will also be equal to 0 from virtual ground concept. So VB equal to VA equal to 0 volt. So applying node analysis at node B, we can write it as V1 minus 0 upon R, V1 minus 0 upon R is equal to 0 minus V01 upon R, 0 minus V01 upon R, because there is no current through this resistor, because this is also 0 potential, this is also 0 potential, so both the terminals are at 0 potential, so current through this resistor will be 0. Now solving, we can get V01 is equal to minus V1, simple. Similarly, we can operate V2 voltage source and killing all the sources. Similarly, we can write V02 is equal to minus of V2, similar expression. When V2 is operating in rest all the sources, that is V1, V3, V4 are killed. Now case 3, when V3 is operating and V1, V2, V4 are killed here. So V3 is operating, V2, V1 and V4 are killed, that is grounded. So this is grounded, this terminal is also grounded, resistor. So essentially this resistor and this resistor are in parallel, because this terminal is at same potential and the other terminal, that is this terminal and this terminal, are at same potential. So these two resistance will be in parallel, these two resistance will be in parallel. So equivalent resistance of these two resistor is R upon 2, that is calculated here, R upon 2, R, and equivalent is R upon 2. Now VA, this VA can be calculated, this VA can be calculated. So equivalent resistance is written here, or equivalent circuit diagram is drawn here, redrawn here. So this is V3 operating, this is R resistor and this is R by 2 resistor. So now VA, this VA can be calculated here, that is this VA. So VA can be calculated here. So VA is equal to V3 upon R plus R by 2 into R by 2, this one. So VA is equal to V3 upon 3. So this is due to, this is output due to V3 source. So similarly we can write, sorry, so this was VA, this was VA. So VB is equal to VA, so this potential will also be equal to this potential. So VB is equal to VA equal to V3 upon 3. Now we can apply nodal analysis at node B. The circuit is redrawn here. So here VA equal to VB equal to V3 upon 3. So VB is equal to V3 upon 3. So we can apply nodal analysis at node B, that is at inverting terminal. Now this resistor and this resistor, these two resistors, so these two resistors are in parallel, R and R in parallel. So equivalent resistance will be R by 2. So we can apply nodal analysis. So 0 minus R by 2, sorry, 0 minus VB, 0 minus VB upon R by 2, the whole resistance equivalent. So 0 minus VB upon R by 2 equal to VB minus V output 3 upon R, this resistor. solving, we can get V output 3 is equal to 3 times VB. So V output 3 is 3 times VB, that is 3 times V3 upon 3. So V output 3 is equal to V3. So V output 3, that is output response or output voltage due to V3 is equal to V3. Now similarly we can calculate here V output 4, that is when V4 is V4 is operating, that is voltage source 4 is operating, and all the voltages are killed. So similarly we can get V output 4 is equal to V4. So the final output can be written here. So final output can be written here. So final output V0 is equal to V01 plus V02 plus V03 plus V04. So we can write it as here minus V1 minus V2 plus V3 and plus V4. So this is written here, V0 is equal to V3 plus V4 minus V1 plus V2. That is potentials V3 plus V4, that was the voltage sources applied at non-inverting terminal, minus of V1 plus V2, these are voltage sources applied at inverting terminal. So this was adder subtractor circuit. So based upon this, I have given one example here. So this is the example. So friends, you have to do it yourself and solve for simplicity or clue. I have given answer here, that is V0 is equal to 10 volt. So this you have to do yourself. So thank you friends, thanks for watching.